Alright, so for the last 4 problems, we have intercept form or factored form. And so with these, you can still tell if it concaves up or down because you look for the a value right here. And so I know that this one's going to concave up, so it's going to have a minimum value. I know that the domain is all reals, and I also know the x-intercepts. So P and Q. So P is 1, and Q is -3. Okay, and I get those values from here and here. For the vertex, you know that the vertex is halfway between the two x-intercept because of symmetry. So I'm going to say x equals 1 plus -3. So I'm looking for the midpoint, the average of the two. So that's -2/2, -1. And for the y, just replace the y with the x with -1. So I have -1 minus 1 times -1 plus 3. So that gives me -2 times +2, which is -4. So my vertex is -1, -4. So then my minimum value is -4, and the range goes from -4 to infinity. So we go ahead and plot what we have. Vertex is -1, -4, and 1, 0, and -3, 0. And, oops, I didn't do the y-intercept. The y-intercept, remember, replace all the x's with 0, and multiply it out and work it out. Or same thing is to take the two constants and multiply them together. And so you get 0, -3. Okay, so 0, -3. And because of symmetry, you know that -2, -3 is also on the graph. And connect your points. And that's it for number 13. Number 14, it concaves up, so it has a minimum value. The domain is all reals. The x-intercepts are -5, 0, and -3, 0. I can get the y-intercept by taking the two values here. 5 times 3 is 15. So 0, 15. So this is one that we're not going to be able to see on the graph, but that's okay. That's happened before. So you just know that the y-intercept is 0, 15, but you're just not going to see it on the graph. For the vertex, we take half the midpoint between -5 and -3. So that's going to be -8 divided by 2, so that's -4. And for the y, we do -4 plus 5 and -4 plus 3. So that gives us 5 minus 4, that's 1. -4 plus 3, that's -1. So the vertex is -4, -1. So the minimum value is -1. The range goes from -1 to infinity. Okay, so let's plot this. -4, -1 right here. -5, 0. -3, 0. I mean, you may want to put in another value because the points are so close together, the 3 points that are there. So I'll just put in a -2. So if x is a -2, I get -2 plus 5 and -2 plus 3. So 5 minus 2 is 3, and 3 minus 2 is 1, so that gives me 3. So -2, 3 is a point, and so I know that -6, 3 will also be a point. So right about approximately right there. Connect the points and you're done. Okay, so for this one concaves down because the a is negative right here. The a is negative. So I have a maximum value. The domain is all reals. The x-intercepts are 2, 0, and 5, 0. Okay, and the y-intercept, we're going to take -2 times -5 is 10. 10 times negative 2 is negative 20. So we're not going to see this on our graph either, just like on the previous one. So it's negative 20. Okay. The vertex, we take the midpoint of 2 and 5. So that's going to be 7 divided by 2, so that's 3.5, right? For the y, replace the x with 3.5, so that's going to give you negative 2 times 3.5 minus 2 times 3.5 minus 5. So that's going to give you 1.5. So negative 2 times 1.5 times negative 1.5. So that's going to give you positive 4.5 when you multiply all three together. So the vertex is 3.5, 4.5. Okay, so that means that the maximum value is 4.5 or 4.5, and the range goes from 4.5, from negative infinity. I wrote it, started wrong. From negative infinity to 4.5 or 4.5. With a bracket right here. Looks like a parentheses. Okay, so plot what you have. I have the vertex is 3.5, 4.5. So 3.5, 4.5 is approximately right here, in the middle of that square. And then 2, 0, and 5, 0, right there. Yep. So something like this. And that's it. Number 16, we have another concave down, so that's going to give us a maximum value. The domain is all reals, and the y-intercept is positive 1 times negative 3 is negative 3, and negative 3 times negative 1/4 is going to be positive 3/4. So 0, 3/4. Okay? The x-intercepts are negative 1 and, oops, I didn't write it correctly. Negative 1, 0 and 3, 0. Okay? Vertex, halfway between negative 1, 0, 3, 0, so that's going to be x equals negative 1 plus 3 divided by 2. That's 2 over 2, which is 1. And then for the y, we put in negative 1/4 times 1 plus 1 times 1 minus 3. So that gives us 2 right here and negative 2 right here. So that's going to be negative 4. So negative 4 times negative 1/4 is positive 1. So 1, 1 is the vertex. 1, 1. The maximum value then is 1, and it goes from negative infinity to 1 for the range. Oops, parentheses there. So plot what you have. 1, 1 is the vertex, and then negative 1, 0 and 3, 0 are the x-intercepts. The y-intercept is hard to graph on this because the graph is so small, so it's hard to distinguish, 3/4 from like a half or whatever, so you don't have to plot that point. So this is enough. This and like this. Okay, and you could see, because it's a vertical compression because of the 1/4, how it's really wide compared to number 15 that has a vertical stretch.